Welcome to the class of mathematics. In today's lecture, we will take up different types of matrices. Row matrix, a matrix of order 1 by n is called the row vector, or the row matrix. For example, matrix U and B are row vectors, as they have only one row. Column matrix, a matrix of order m by 1, is called column vector or column matrix. For example, the matrix C and D are column matrices, as they have only one column. 0, or null matrix, a matrix whose all elements or entries are 0, is called zero matrix, and it is generally denoted by O, m by n. If there is no loss of generality, then zero matrix can be denoted by uppercase letter O. Examples of zero matrix are rectangular matrix, a matrix in which the number of rows n is not equal to the number of columns n, that is n is not equal to n, is called rectangular matrix. Examples are square matrix, a matrix in which the number of rows n is equal to the number of columns n, that is n is equal to n, is called square matrix. Examples are since in square matrix the number of rows m is equal to the number of columns n, so instead of writing its order as n by n, it is customary to write it just n. A square matrix A equal to A by J is said to be diagonal matrix if A by J is equal to 0 for all I is not equal to J, and at least 1 A by J is not equal to 0 for I is equal to J. Thus, in a diagonal matrix, all the entries, except the entries along the main diagonal are 0. Examples of diagonal matrix of order 1, 2, and 3 are a square matrix A by J is said to be a scalar matrix if A by J is equal to 0 for all I is not equal to J, and A by J is equal to K for I is equal to J, where K is a non-zero scalar, or a diagonal matrix whose entries along the principal diagonal are equal is called a scalar matrix. A square matrix in which all the diagonal entries are 1, and the rest are all 0 is called a unit, or identity matrix, denoted by IN. Thus, a square matrix IN, A by J of order m is said to be a unit matrix if A by J is equal to 1 for I is equal to J, and 0 for I is not equal to J. A square matrix is said to be an upper triangular matrix if all the elements below the main diagonal are 0. Thus, the square matrix A by J of order m is said to be an upper triangular matrix if A by J is equal to 0 for all I is greater than J. For instance, the above-mentioned matrices are upper triangular matrices. A square matrix is said to be a lower triangular matrix if all the elements above the main diagonal are 0. More precisely, a square matrix A by J of order m is said to be a lower triangular matrix if A by J is equal to 0 for all I is less than J. For instance, the above-mentioned matrices are lower triangular. A square matrix which is either upper triangular or lower triangular is called a triangular matrix. Observe that a square matrix that is both upper and lower triangular simultaneously will turn out to be a diagonal matrix. Let A be a matrix of order m by m, then a matrix of order n by m is called the transpose of the matrix A and is denoted by A to T. That is, the transpose of a matrix is obtained by interchanging rows and columns of A. A square matrix A of order n is said to be symmetric if transpose of A is equal to A. That is, if A by J is a symmetric matrix of order n, then A by J is equal to A, J by for all I and J. A square matrix A is said to be skew-symmetric matrix if transpose of A is equal to negative time A. If A by J is a skew-symmetric matrix, then A by J is equal to negative time A J, I for all I is not equal to J, and A by J is equal to 0 for I is equal to J. That is, the diagonal elements of a skew-symmetric matrix are 0. Please subscribe, like, and share my channel. Maths for You by Ada Rahman. And do not forget to press the bell icon for more videos. Thanks for watching.